Good morning, students. So we have seen in the previous class about the session of the phases of the compiler and the various tools. Now today let us see predictive parser. So let me go for the slideshow. Okay, students. So today let us see that predictive parser, right, which comes under our unit 2, syntax analyzer, otherwise called as parser. So you all know that there are two types of parser, top-down parser and bottom-up parser, right? So predictive parser comes under our top-down parser, right? So it is called as LL1, right? The first L stands for the left to right reading and second L stands for the leftmost derivation, right? So predictive parser can be constructed for a class of grammars called as LL. L stands for left to right reading. Second L stands for the leftmost derivation. The last one says that you are going to read or scan one symbol at a time. And this comes in the top-down parser. It means that there should not be any recursion and your grammar should not be ambiguous, right? So no left recursive or ambiguous grammar can be LL1. It means that we are supposed to eliminate the left recursion and we are supposed to convert the ambiguous grammar to unambiguous grammar by eliminating the ambiguity. Right, so grammar G is called LL1 if and only if whenever A tends to alpha or beta are two distinct productions of G, the following condition holds. First point, first of you are going to find the first of alpha and first of beta and that must be disjoint. This is to be able to deterministically guess the production. Okay, finally in the last step after we construct the predictive parsing table, you will understand this. Now the second important point is at most one of the strings alpha or beta can derive epsilon since first of alpha and first of beta are disjoint, right? Next, if A alpha tends to epsilon, then first of beta and follow of A must be disjoint. These are the conditions of our LL1 parser. Now let us see the algorithm for construction of the parsing table. Now the input is the given grammar. Your output is the parsing table M. So for each production, A tends to alpha, you are supposed to do the following, right? So for each terminal A in first of A, add A to alpha to M of A comma alpha. That is, you are writing that respective production in the table. The name of the table is M. You are having the two parameters. The first one will be your non-terminals of the given context-free grammar, and the next one alpha will be your terminals, right? As you all know, the context-free grammar will have four parts: non-terminals, terminals, productions, and you'll be having the starting symbol, right? If epsilon is in first of alpha, then for each terminal B in follow of A, you are supposed to put that production in the respective table for the input symbols B. If B is dollar, then also add A tends to alpha to M of A comma dollar. So in our terminals, we'll be having dollar, which will be considered as the end of the input string. If there is no production in M of A comma A, then we are saying that set M of A comma A to error. Now let us see the example. E tends to T dash, E tends to plus T dash, or epsilon, T tends to FT dash, and T dash tends to star FT dash or epsilon. F tends to open bracket, E close bracket ID. My dear students, this production is unambiguous grammar, right? And the ambiguous grammar for this production is E tends to E plus E, E tends to E star E, E tends to open bracket, E close bracket, and ID, right? Where E stands for expression. And that we are converting to E tends to E plus T or T, T tends to T star F or F tends to open bracket, E close bracket or ID. And now we'll eliminate the left recursion and we'll get the resultant production, right? So after finding the first and follow, right, we are going to generate the parse table, right? So now here the given parse table is you are having the non-terminals E dash, T dash, and F, and the terminals are ID plus star, open bracket, close bracket, and dollar. Actually, dollar we are including because our end of the string will have dollar. So we'll be checking whether the given string, right, with that is A plus B plus C is valid or invalid, where A, B, C will be set as an identifier 1, 2, and 3 by the lexical analyzer. Our parser syntax analyzer will check whether the given string is valid or invalid using the predictive parser. This is one type of parser in our top-down. Now, table-driven predictive parser. A predictive parser can be built by maintaining a stack explicitly. So that's what I said. The end of the input string will be stack, and in your stack, initially you will be pushing the dollar. You all know that stack is last in, first out, and the two basic operation of stack is push and pop. The table-driven parser has an input buffer, stack containing sequence of grammar symbols, passing table, and an output string. The input buffer contains a string to be passed followed by dollar. Initially, the stack contains a star symbol of the grammar on the top followed by dollar. Okay, right? The passing table deterministically guesses the correct production to be used. Right, so this is a flowchart. You'll be having the table, parser, stack, and the input buffer. So in the input buffer, you'll be having ID plus ID into ID. Then you are having the predictive parser, and the table is with you. And with the help of the stack, using the given table, you do the respective push and pop operation of the given production in the table. And finally, if you reach the end of the input string, and if in the stack starting symbol is available, it means that the given string is valid. Now, the procedure for the predictive parser. The current symbol of the input string is maintained by a pointer, say IP. In every step, consider the set A, alpha, where A is a symbol pointed by the IP and alpha is the top of the stack. If alpha is a non-terminal, then see the table cell M of alpha, A for the production. If M of alpha, A is a valid production, then pop the stack, push the production into the stack. If M of alpha, A is error or blank, then report an error. If alpha is a terminal, then pop it from the stack and also increment the input pointer IP to point the next symbol in the input string. The output will be the set of productions. The following example illustrates the top-down predictive parser using passing table. Right, now let us go for an example, ID plus ID into ID. Right, so given the input string ID plus ID, right? So you are having ID plus ID into ID using the given passing table, right? So this is the various actions done using the predictive parser. So you check whether it is matched or not. So your input string is ID plus ID into ID dollar. So the condition is we put dollar at the end, and the condition is inside the stack, I push dollar, then the starting symbol E, right? Now E for ID, what is that? It is TE dash. So I push TE dash. So as I proceed, finally I'll reach the end of the input string, and in the stack you'll be having dollar, and in the input string also you'll be having dollar. It means that the string is accepted. Right. So with the help of the predictive parser, that is one type of top-down parser, we have identified whether the string is valid or invalid. Thank you, students. Thank you, students.